Hi all, today we are going to discuss a XAT related special session. As many of you are aware that XAT exam is going to be conducted on January 5th. Generally, XAT exam quantitative aptitude is at a moderate to difficult level. Now we will take a few sessions, we'll understand the kind of questions that are coming in XAT examination and the way to solve that kind of questions. Every video which I take will cover a particular topic. That means this video is all about questions from number system. Next video I will take the questions from algebra. Next I will take the questions from geometry. Right? Like that I will touch the most important topics of XAT examination that will come. Without wasting too much of time, let us get into it. Please remember that the kind of questions that are coming are of difficult level. Let us look at the first question. All are very good quality questions. See the first question. Find the positive. Please read the question once. Find the positive difference of two natural numbers. Right? I require, if the natural numbers are n1 and n2, I require the positive difference of, right, n1 and n2. n1 minus n2, I need the positive outcome. Right? Whose sum is 85 and LCM of the numbers is 102. N1 plus N2, this sum should be N1 plus N2, this sum should be 85 and LCM of these numbers, LCM of N1 comma N2, this should be 102. These are the two conditions the number should satisfy. Right? Now what we'll do is, we have to find out what are that numbers where the LCM of that numbers is 102 and the sum of the numbers is 85. Now, there is one concept. If you know that concept, you can solve this question right little easily. Concept is, listen carefully, sir. Concept is LCM of, for example, 34 comma 51. LCM of 34 comma 51. I am taking two random numbers, 34 comma 51. 34 can be written as 17 into 2. 51 can be written as 17 into 3. Whenever we are computing the LCM of the numbers, the number which is common in all the numbers, we'll write it outside 17. 2 and 3 are co-primes. LCM of co-primes is their product. 17 into 6 is 102. 17 into 6 is 102. Now, if you observe carefully, 34 plus 51. 34 plus 51, sum is 85. 34, 51, LCM is 102. LCM is 102. Now, if you see 34 and 51, two numbers are getting satisfied. Now, what we have to observe is LCM of n1 comma n2. This is, right, I just took a random example to tell you that there exist two numbers whose sum can be 85 and LCM can be 102. But how are we sure that the numbers are only 34 and 851? Let us see. 102 can be written as 17 into 2 into 3. 17 into 2 into 3. Now, answer contains 17, 2 and 3. Answer contains 17, 2 and 3. Now, listen carefully, sir. Concept. Answer contains 17, 2 and 3. Suppose if you see here, LCM of 6 and 9, it is 18. LCM of 4 comma 6, it is 12. LCM of 4 comma 6, it is 12. Now, answer 12, it is divisible by 3. Answer 12, it is divisible by 3. Right? It is present in at least one number which is in input which is divisible by 3. Answer here, it is divisible by 9. That means at least one number, it is divisible by 9. Now, if you observe carefully, answer it is divisible by 17. That means at least one, either n1 or n2, right, or both can be divisible by 17. Can be divisible by 17. Now, if you see here, so if n2 is divisible by 17, I require 102. Answer, it is divisible by 2. That means at least one number, it can be divisible by 2. At least assume this number, it is divisible by 2. It is divisible by 2, right? I require 102, 17 into 2, 3. Answer, it is divisible by 3. That means at least one number, it is divisible by 3. At least one number, it is divisible by 3. That means either it can be divisible by 3 or it can be divisible by 3. Or it can be divisible by 3. Suppose if I take this is divisible by 3, right? 17, it is 51 and 2. 51 plus 2, 53. But the question is, sum is 85. So, this is not. If this is divisible by 3, 2 and 3, 6. 6 and 17. LCM it is 102 plus 6 plus 17. 23 it is, right, but right hand side it is 85. That means this case of only one number divisible by 17, it is not possible. That means both of them should be divisible by 17. So 2 means at least one can be divisible by 2, at 3 means at least one can be divisible by 3. That means numbers definitely has to be 17 2s are 34, 17 3s are 51. N1 is 34, N2 is 51. N1 plus N2 is 51 plus 34, which is 85. What is the question? Difference is asking. 51 minus 34, it is 17. 51 minus 34, it is 17. I hope the idea it is very much clear. The entire question, it's a very, very good question. It discusses one concept. If answer, it is divisible by 9, input one number should be divisible by 9. At least one number, sir. It can be all the numbers, but minimum one number should be divisible by 9. Answer, it is divisible by 3. That means input one number, it should be divisible by 3. So, answer, it is divisible by 17. At least one number, either this should be divisible or this should be divisible, or both. First case, only one number I am keeping. 2, either this or this, I kept this. 3, either this or this, but it is not satisfying the condition. N1 plus N2 equivalent to 85. Therefore, I eliminated. I got both the cases. Yes, if I take both of them are divisible by 17, I got 51 and 34. 51 plus 34, it is 85. So, the difference is asking 51 minus 34. Answer for this question is 17. I hope the concept it is very much clear to you. Good question, quality question, right, based on LCM. Second one, how many divisors? Divisors means how many factors? How many factors? How many factors does the number 18,000 have, including one and itself? In simple way of asking, he is asking how many factors are there for 18,000. Number of factors. Number of factors for 18,000. 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 Now see here, how to find out the number of factors? First write this number as a product of prime powers. So this will be 18 into 10 cube. It is 18 into 10 cube. 18 it is 2 into 3 square. 2 into 3 square. 10 cube it is 2 cube into 5 cube. 10 cube it is 2 cube into 5 cube. So, this will be 2 power 1, 2 power 3, 2 power 4 into 3 square into 5 cube. So, if I write 18,000 as a power of prime factors, it is 2 power 4 into 3 square into 5 cube. How many factors are there for this number? 2 power 0 to 2 power 4. All powers of 2 starting from 0 to 4 will divide 2 power 4. 0 to 4, 5 combinations. 3 square, all the powers of 2, 3 power 2 starting from 0 to 2. 0 to 2, 3 combinations. 5 power 3, 5 power 0 to 5 power 3, 0 to 3, 4 combinations. 5 into 3 into 4. 5 3s are 15, 15 4s are 60. How many factors are there for 18,000? 60. All the answer options got 60. Next one, also find the sum of all the factors. So first question, number of factors for 18,000. It is clear to us. All the options got 60. So whenever you are solving this kind of questions, do not find the number of factors first, because all the options have got 60. Start with finding the sum of the factors. The next question is, find the sum of the factors. Find the sum of the factors for 18,000. Find the sum of the factors for 18,000. How to find out the sum of factors for 18,000? 18,000 it is 2 power 4 into 3 square into 5 cube. 2 power 4 into, right, 3 square into 5 cube. Now see here, how to find out the sum of factors? Start from all the powers of 2. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. 2 square, 2 cube, 2 power 4. 2 power 0 plus 2 power 1 plus 2 square plus 2 cube plus 2 power 4. Again for 3 square it is 3 power 0 plus 3 power 1 plus 3 power 2. All the powers of 3 starting from 0 to whatever the power. Then it is 5 power 0 plus 5 power 1 plus 5 power 2 plus 5 power 3. Whatever the answer that we will get, that itself will be the answer. That itself will be the answer. Now see here, sir. Right? If you see 3 square it is 9. 9 plus 3 12. 12 plus 1 13. 2 power 0 it is 1 plus 2 3. 3 plus 4 7. 7 plus 8 15. 15 plus 16 31. 31 into 9 plus 3 12. 12 plus 1 13. 31 into 13 into 125 plus 25, 150, 150, 5 power 1, 5 plus 1, 6, 6 plus 25, 31, 31 plus 125, it is right 156, 31 into 13 into 156, 31 into 30 into 156. Now if you see, if I use the concept of digital sum, 31, 3 plus 1 it is 4. 1 plus 3 it is 4, 6 plus 5 11, 11 plus 1 12, 12 it is 3, 6 plus 5 11, 11 plus 1 12 it is 3, 4 4s are 16, 16 3s are 48, 48 is 4 plus 8 12, 1 plus 2 3. So answer digital sum should be 3. Where it is 3, please check it out. 6 plus 6 12, 12 plus 2 14, 14 plus 16, 14 plus 16, how much it is? 33. 14 plus 2, 16. 16 plus 8, 24, 30. Yes. 14 plus 2, 16, 30. It is also 30. 16, 22. All the digital sums are 30. So here, if you observe carefully, write unit digit. 6 3s are 18, 8. 8 1s are 8. Answer unit digit should be 8. Answer unit digit should be 8. This is out. Third option it is out. Next one, 31 into 13 into 156. Answer should be divisible by answer should be divisible by, write 13. Answer should be divisible by 13. What is the divisibility rule of 13? Start from rightmost. Take a group of 3 digits and add it. 868 minus 62. 806. 13 6 are 78. 26. Yes, it is divisible by 13. Start from rightmost. Take a group of 3 digits and add. 268 minus 68. 200. No, not possible. 288 minus 66. 222. 222. It is also not divisible. So answer for this question is option A. What you do is, either you use the concept of digital sum, but unfortunately here all the answer options have digital sum same. So then I used the concept of unit digit. 6 3s are 18, 8 1s are 8. The options where the unit digit is not 8, it is eliminated, but 3 options are left. Then I used the divisibility rule of 13. What is the divisibility rule of 13? Start from rightmost. Take a group of 3 digits, alternatively plus minus. 868 minus 62 is 806. 806 it is divisible by 30. Beautiful question. In this question, he is asking about how to find out the number of factors and how to find out the sum of the factors. How to find out the sum of the factors. To find the sum of the factors, what we'll do is start from the lowest power of 2, 2 power 0 to 2 power 4, 3 power 0 to 3 power 2, 5 power 0 to 5 power 3. Right? Add all the powers of a prime base starting from 0 to a given power and do the product. I hope the idea it is very much clear to you. I hope the concept it is very much clear. Good question it is. N is given by, see the third question, it is based on right recurring decimals. N is 0.12345. That 1, 2, 3, 4, 5. That 5 digits are only repeating. So I am keeping a bar. So M is equivalent to 0.98765. 98765. That 98765 are only repeating. 98765 are only repeating. So N is 0.12345, 12345 bar. M is 0.98765. On 98765 there is a bar. Now if you see, right, so this is nothing but how to convert an recurring decimal into fraction. Whatever the number that is there, please write down after dot. 1, 2, 3, 4 by, on how many digits bar is present? On 5 digits bar is present. So here it is 5 nines. Here it is 5 nines. M it is 0.98765 bar. So here it is 98765 divided by, on how many digits bar is present? 5 digits. So this will be 5 nines. This will be 5 nines. 98765 by 5 nines, 1, 2, 3, 4, 5 by 5 nines. Now if you see denominator here 5 nines are there, here 5 nines are there. Now if you observe carefully, what is the question? N plus M in its lowest terms. N plus M in its lowest terms. Now if you observe carefully, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 plus 98765. So here it will be 5 plus 5, 10. It is 11. Here also 11. It is right. 5 ones 0. It is 5 ones 0 ending by 5 nines. 5 ones 0 ending with 5 nines. Which option is satisfying this condition? Option number C. Option number C. Only thing what you should know in this question is how to convert a fraction into recurring decimals. N is 0.12345, right? Bar is present on 5 digits. So denominator contains 5 nines. Here after dot, bar is present on 5 digits. So 9 it is will come 5 times. If I add simply, it is 5 ones 0 divided by 5 nines. Very, very easy question. Not at all a difficult question. If you know how to convert that recurring decimal into fractions. I hope the idea it is clear. Next one. X is given by minus 3.7. X is given by minus 3.7. Then the integral part of X is minus 4. That means this is a concept based on greatest integer function. X can be written as integer part of X plus fractional part of X. X is right greatest integer of X plus fractional part of X. For example, 4.2 is there. 4.2 I can write it as 4 plus 0.2. 4 plus 0.2. Greatest integer point of 4.2 is 4. Suppose if it is minus 3.7, right? This can be written as minus 4 plus 0.3. We are using greatest integer function, GIF. We are using greatest integer function. What do you mean by greatest integer function? Greatest integer that is just less than 4.2, which is 4. 4 plus 0.2. Greatest integer of minus 3.7 is greatest integer that is just less than minus 3.7, right? It is minus 4 plus 0.3. It is minus 4 plus 0.3. That means this is, if it is minus 3.7, this can be written as minus 4 plus 0.3. This can be written as minus 4 plus 0.3. That means what is the greatest integer function of minus 3.7? Minus 4. What is the fractional part of x? It is 0.3. What is the fractional part of x? It is 0.3. So answer for this question is 0.3. Greatest integer functions are highly repetitive questions that are coming in multiple examination. Again, I will define greatest integer function GIF. GIF means greatest integer that is less than or equivalent to the given value. Greatest integer, greatest integer, greatest integer less than or equivalent to x. Greatest integer less than or equivalent to x. Greatest integer less than or equal to x. Less than or equal to x. These are called greatest integer functions. 4.2. What is on a number line? If 4.2 is here, greatest integer that is just less than 4.2. What it will be the answer? 4. So 4 plus 0.2. If it is minus 3.7, greatest integer that is just less than minus 3.7, which is minus 4. So greatest integer less than or equivalent to x. Greatest integer less than or equivalent to x. I hope it is clear. That is the reason we wrote it as minus 4 plus 0.3 instead of minus 3 plus 0.7. It is clearly mentioned that integral part of x is minus 4. So you need to write minus 3.7 as minus 4 plus 0.3. I hope the concept it is very much clear. Next one. Question. This kind of questions based on divisibility rules are very, very important for your exam. M39048458N. M39048458N. It is divisible by 8 and 11. It is divisible by 8 and 11. What is the divisibility rule of 8? Last 3 digits should be divisible by 8. What is the divisibility rule of 8? Last 3 digits should be divisible by 8. Last 3 digits should be divisible by 8. Last 2 digits already given. 58N. 58N. It is already divisible by 8. Already divisible by 8. 8 sevens are 56. So 2 is remaining. That means n should be 4. N should be 4. If n is 4, this number will become 584 divided by 8. 8 sevens are 56. 24 will be 8 threes are 24. That means n value, it is very clear that it is 4. N value, it is very clear that it is 4. 8 divisibility rule is last 3 digits should be divisible by 8. So n we got it. We will replace it. M3904845884. This should be divisible by 11. 11 means sum of odd places. Sum of odd places minus sum of even places. Sum of odd places minus sum of even places. Sum of odd places minus sum of even places. It should be 0 or it should be divisible by 11. Places minus sum of even places should be divisible by 0. Now what we'll do is, Now n anyway we got it as 4. So m 390,484,58n, 584. This number should be divisible by 11. Sum of odd places minus sum of even places. 5 plus 4, 9, 17, 17 plus 3, 20. This is odd places. Even places, 12 plus 4, 16, 16 plus 9, 25. So that means 25 plus m minus 20, it should be right 0 or it should be divisible by 11. 25 minus 20, f 5. So this will be 5 plus m is equivalent to 11. That means m will be 6. If m is 6 and n is 4, m6 n4, answer for this question will be 10. Answer for this question will be 10. I hope the idea it is very much clear to you. This number, it is divisible by 8 and 11. For a number to be divisible by 8, last 3 digits should be divisible by 8. 58n should be divisible by 8. So 8 sevens are 56. 24 it is divisible. That means n value it is 4. I kept n value 4. Sum of odd places minus sum of even places, it should be 0 or divisible by 11. 5 plus 4, 9, 9 plus 8, 17, 17 plus here, right, odd places. 5 plus 4, 9, 9 plus 8, 17, 17 plus 3, 20. So even places, it will be 8 plus 4, 12, 12 plus 4, 16, 16 plus 9, 25 plus m. 25 plus m minus 20, it should be divisible by 11. That means m value will be 6. If m is 6, n is 4, m plus n will be 10. Good question based on the concept of divisibility rules. I hope the idea it is very much clear. Next question. What is the smallest positive integer? There is a number which when divided by 10, 9, 8, 7 and 6. 10, 9, 8 and 6. They leave a positive reminders of. They leave a positive reminders of 9, 8, 7, 6, 5. 98765. There is a number n when divided by 10, 9, 8, 7 and 6. Positive reminders are 98765. All the positive numbers are different. Now we will use the concept of negative reminders. Negative reminders. Suppose 19 divided by 5. 5 3s are 15. Positive reminder it is 4. 5 3s are 15, positive reminder it is 4. Negative reminder will be 5 4s are 20, negative reminder it is minus 1. Negative reminder it is minus 1. Sometimes when the positive reminders are different, check it out whether the negative reminders are same. Check it out whether the negative reminders are same. How you got negative reminder? 4 minus 5 is minus 1. 4 minus 5 is minus 1. So negative remainder will be 9 minus 10 is minus 1, 8 minus 9 is minus 1, 7 minus 8 is minus 1, 6 minus 7 minus 1, 5 minus 6 minus 1. All the negative reminders are same. When positive reminders are different, check it out whether the negative reminders are same. 9 minus 10 minus 1, 8 minus 9 minus 1, 7 minus 8 minus 1, 6 minus 7 minus 1, 5 minus 6 minus 1. That means negative reminders are same. Then what will be the number? So the number is perfectly divisible by, right, 10, 9, 8, 7, 6. Number is perfectly divisible by 10, 9, 8, 7, 6. In all the cases, negative remainder is minus 1. In all the cases, negative remainder is minus 1. That means this number is perfectly divisible by 7 and it gives a remainder minus 1. And it gives a remainder minus 1. Answer when divided by 7, it should give a remainder minus 1. Answer when divided by 7, it should give a remainder minus 1. So start from rightmost, take a group of 3 digits alternatively plus minus. That is the divisibility rule for 7. Divisibility rule for 7 is start from rightmost, take a group of 3 digits alternatively plus minus. 519 minus 2, 517. 219 minus 2, 217. 18 minus 2, 16. 520 minus 2, 518. 17. 7 2s are 14. Positive remainder 2. Not possible. 7 3s are 20. These also not possible. This is 7 7s are 49, 28. Not possible. 7 3s, 7 7s are 49, 27. 7 4s are 28. Negative remainder minus 1. Answer when divided by 7, it should give negative remainder minus 1. In this question, all the positive reminders are different. All the positive reminders are different. So what we will do? We will find out the negative remainder. 9 minus 10 is minus 1. 8 minus 9 is minus 1. 7 minus 8 minus 1. 6 minus 7 minus 1. 5 minus 6 minus 1. So all of them got the negative remainder same. So answer will be LCM of 109876 into K minus 1. Answer when divided by 7, negative remainder is minus 1. I hope the idea it is very much clear to you. Good question based on the concept of a negative remainder. What is the remainder? These remainder questions are quite popular in various exams. What is the remainder one? 2009 into 2010 into 2011, it is divided by 12. It is divided by 12. It is divided by 12. Now, if you observe carefully, the best way to solve this kind of questions is use Chinese remainder theorem. Chinese remainder theorem. Chinese remainder theorem states if there is 12, write this 12 as a product of coprimes. As a product of coprimes. 12 it is 3 into 4. 12 it is 3 into 4. That means first divide the numerator by 3. Then divide the numerator by 4. If I divide it by 3, 2010, it is perfectly divisible by 3. Because 2010, sum of the digits it is 3. It is perfectly divisible by 3. So, these perfectly divisible by 3. That means answer should be perfectly divisible by 3. Answer should be perfectly divisible by 3. 11 is out, 1 is out. Option A is out, option D is out. All these are clear. A out, D out. Next one, 4. For divisibility rule of 4 is last 2 digits should be divisible by 4. 4 2s are 8, remainder 1. 4 2s are 8, remainder 2. 4 2s are 8, remainder 3. 3 2s are 6, 6 1s are 6. 6 when divided by 4, remainder should be 2. Answer when divided by 4, remainder should be 2. Answer when divided by 4, remainder should be 2. Here it is 0. So answer for this question is option B. Answer for this question is option B. I hope the idea it is very much clear. 2009 into 2010 into 2011 divided by 12. 12 it can be written as 3 into 4. That means numerator should be divisible by 3. Numerator should be divisible by 4. Divisibility rule of 3 is sum of the digits should be divisible by 3. 2010, sum of the digits is 2 plus 1, 3. It is perfectly divisible by 3. So answer should be perfectly divisible by 3. It is 4. Divisibility rule of 4 is last 2 digits should be divisible by 4. 4 2s are 8, remainder 1. 4 2s are 8, remainder 2. 4 2s are 8, remainder 3. 3 2s are 6. 6 when divided by 4. 4 1s are 4. Answer will be 2. Answer when divided by 4. Remainder it should be 2. Answer when divided by 4. Remainder should be 2. I hope the concept it is very much clear to you. I hope the idea it is very much clear. Next one, the positive integers 30, 72 and n have the property that product of any two of the numbers is divisible by the third. That means 30 into n. There are three numbers 30, 72 and n. You multiply any two, it is divisible by the third. That means 30 into n. When I divide by 72, remainder it is 0. Next one, 72 into n. When divided by 30, remainder it is 0. Or 30 into 72. When divided by n, remainder it is 0. This is the mathematical expression of the given question. Product of any two, it is divisible by the third. Product of any two, it is divisible by the third. Now, if you see here, listen carefully, sir. With a lot of good understanding of the number system, we will solve this problem. 72 into n is divisible by 30. 72 does not have a multiple of 10. 72 does not have a multiple of 10. 72 it is 2 cube into 3 square into n divided by 30 it is 2 into 3 into 5. 2 into 3 into 5. It is 0. 2 cube is divisible by 2. 3 square is divisible by 3. That means n should have 5 power 1 related. N should have 5 power 1 related. Are you all with me? Similarly, 30 into n. 30 it is 2 into 3 into 5 into n divided by 2 cube into 3 square. 2 cube into 3 square. Remainder it is 0. Denominator 2 power 3 is there. Numerator only 2 power 1 is there. That means n should have 2 square. N should have 2 square. Numerator there is 5 power 1. Denominator numerator 3 power 1. Denominator 3 square. That means another 3 power 1 should be there. That means n should be divisible by 12 and n should be divisible by 5. That means n should be divisible by 12 and 5. N should be divisible by 12 and 5. 12 and 5 it is 60. So the value of n is 60. The value of n is 60. What is the sum of the digits of the smallest possible value? 60 sum of the digits is 60 sum of the digits will be 6 plus 0 6. Sum of the digits for 60 will be 6 plus 0 it is 6. 6 plus 0 it is 6. I hope the idea it is very much clear. Positive integers. There are three positive integers 30, 72 and n. Product of any two it is divisible by third. 30 into n is divisible by 72. 72 into n divided by 30 remainder 0. 30 into 72 divided by n remainder 0. That means here if you observe 2 cube is divisible by 2, 3 square is divisible by 3. N should be a multiple of 5. Here 2 power 3 is there. Only 2 power 1 is there in the numerator. That means n should have another 2 square. Here 3 power 1. N should have another 3 power 1. 2 square into 3 is 12. N should be divisible by 12. N should be divisible by 5. What is the number that is divisible by both 12 and 5? 60. What is the sum of the digits for 60? It is 6 plus 0, 6. Good question. This kind of questions are frequently coming in multiple examinations. So answer for this question is 6. I hope the idea it is very much clear. Next one. This kind of question also came in the CAT examination. Original questions are This is a very, very important type of questions. See the question. If the pattern below continues, until all the letters of alphabets are shown, how many letters including repetition will precede the last Z. First A is written once, first letter is written once, second letter is written twice, third letter is written thrice, fourth letter is written four times, fourth letter it is written four times, and the process continues. Before Z, write how many times? Z is 26. 26 alphabets are there. First alphabet is written once, second alphabet is written twice, third alphabet is written thrice, 26th alphabet is written 26 times. Before Z means here Z is written 25 times. Here Z is written 25 times. Actually Z is 26th alphabet. 26th alphabet is written 26 times. But before Z there are 25 more Z's are there. That means here Y is written 25 times. Here Y is written 25 times. Y is the 25th alphabet. 25th alphabet is written 25 times. 26th alphabet is written 26 times. But before Z, Z is written 25 times. Now, the first position of A is 1. B is ending at third position. Second alphabet is ending at 1 plus 2, third position. Third alphabet it is ending at 1, 2, 3, 4, 5, 6. Sixth position, which is 1 plus 2 plus 3. Third alphabet ending at sixth position. Fourth alphabet ending at 1 plus 2 plus 3 plus 4. That means nth alphabet. That means nth alphabet is ending at 1 plus 2 plus 3 and so on up to nth position. 1 plus 2 plus 3 and so on up to nth position. First alphabet is ending at first position. Second alphabet is ending at third position. Third alphabet is ending at sixth position. That means nth alphabet is ending at 1 plus 2 plus 3 and so on up to nth position. That means 25th alphabet is ending at 1 plus 2 plus 3 and so on up to 25, which is n into n plus 1 divided by 2. It is 325. 325 plus Z is written 25 times before the final Z. 325 plus 25. That means before Z, write how many letters are written? 350 letters are written. Before Z, 350 letters are written. First alphabet, first position. Second alphabet, third position, 1 plus 2. Third alphabet, it is 1 plus 2 plus 3. 25th alphabet, it is 1 plus 2 plus 3 and so on up to 25, which is 25 into 26 by 2, 325. 325th position, Y it is written. Z is written 26 times. Right before Z, 25 are there. 325 plus 25. What will be total letters that are written? 350 it is written. I hope the idea it is very much clear to you. I hope the concept it is very much clear to you. Very, very good questions. This kind of same question came in the CAT previous year question. Now, if you see, for a real number, right, this bracket denotes the great integral part of x. Integral part of x, what will be the value? A similar kind of question also came in the management examination. Now, if you see, these 1 by 2, these 1 by 2 plus 1 by 100, these 1 by 2 plus 2 by 100 and so on up to 1 by 2 plus 99 by 100. Now, if you observe carefully, sir, 1 by 2 it is 50 percentage. 1 by 2 it is 50 percentage. Now, if I take 1 by 2 plus 50 by 100, 1 by 2 plus 50 by 100. 50 by 100 is 1 by 2. 1 by 2 plus 1 by 2, it is 1. 1 by 2 plus 1 by 2, it is 1. That means greatest integer of 1, it is 1. 1.2, it is 1. 1.99 also, it is 1. From 2 onwards, it is 2. We require, right? Now, if you see here, these are all 0 0 something and so on up to 1 by 2 plus 99 by 100. Till here it is 1. Why it is 1? So, if I take 1 by 2 as 50 by 100, 50 plus 99, 149 by 100, 1.49. 1.49 greatest integer, it is 1. That means from 50 to 99, total 50 numbers. Total 50 numbers will give you 111. 50 into 1 is 50. 50 into 1, it is 50. 1 by 2 plus 50 by 100. 50 by 100, it is 1 by 2. 1 by 2 plus 1 by 2, it is 1. 51 by 100. 51 by 100 is, right? 50 by 100 plus 51 by 100. 101 by 100. 1.01. That is also 1. From 50 to 99, total 50 numbers are there. Each number value will be 1. So 1 into 50, 50. Sir, what will happen before? All these are. That means from 1 by 2 plus 1 by 2 plus 1 by 100 and so on up to 1 by 2 plus 49 by 100. All these will be zeros only. Why? Because if you see it also, right, anything less than 1, from 0 to anything less than 1, greatest integer function, it is 0. So, from 1 by 2 plus 1 by 2 plus 1 by 100 till 1 by 2 plus 49 by 100, it is 0. From 50 by 100 to 99 by 100, it is 1. 50 ones are 50. Answer for this question, it is 50. I hope the idea, it is very clear to you. Idea for this question, it is very much clear to you. Greatest integer function, very important topic that comes in your examination. I hope the first 10 problems are very. Look at this 11th question. There is a 6-digit number which begins with 1. There is a 6-digit number which begins with 1. Let the right number is beginning with 1. That means remaining 5-digit numbers are there. Let me call it as A, B, C, D, E. This is a 6-digit number. It is beginning with 1. If this digit is moved from the extreme left to the extreme right without changing the order of the digits, the new number, that is 3 times the original number. This is the original number. So, if 1 is moved from extreme left to extreme right, this is the new number. This is a new number, it seems. It is 3 times the original number. 3 times 1 A, B, C, D. This expression, I hope it is clear. Leftmost one, it is moved to rightmost one. So, leftmost one moved to rightmost one. The new number, it is 3 times the original number. That means, if the original number is 1 A, B, C, D, E into 3, the new number will be A, B, C, D, E 1. Are you all with me? 1. We have to decode the values of A, B, C, D, E. Once we find the values of A, B, C, D, E, sum of the digits in 1 A, B, C, D, E, here also it is 1 plus A plus B plus C plus D plus E. Here also it is 1 plus A plus B plus C plus D plus E. I will tell you 2 ways to solve this problem. Method 1. Here it will be 1 A, B, C, D, E into 3. It is A, B, C, D, E 1. Now, if you observe carefully, E multiplied by 3, I am getting 1. So, E should be 7, because 7 3s are only, it is 21, right? 3 multiplied by which digit? I will get 1. 3 7s are 21. So, 7 3s are 21, 1, 2 carried. Here, E will become 7. 3 multiplied by D plus 2, I should get 7. 3 ones are 3, 3 plus 2 5, 3 twos are 6, 6 plus 2 8, 3 fives are 15, 15 plus 2 17. That means D will be 5. D will be 5. 17 means 1 carried. 3 multiplied by C plus 1 should give you 5 at the end. 3 eights are 24 plus 1, 25. That means C will be 8. C will be 8. Here C will be 8. 24 plus 1, 25. 3 multiplied by, right, B plus 2, I should get 8. 3 twos are 6. 6 plus 2, 8. I hope the idea it is very much clear. So, 2. Here, if you solve it, you will get 4. That means the entire value it is 142857. 142857 into 3, I will get 428571. 428571. This is the number. Leftmost one is becoming a rightmost one. Again, I am explaining. Listen carefully. 3 multiplied by E, I should get 1 at the end. 3 ones are 3, no. 3 twos are 6, no. 3 threes are 9, no. 3 sevens are 21. That means E has to be 7. E has to be 7. So 3 sevens are 21. 1, 2 carried. 3 multiplied by D plus 2, I should get 7 at the end. 3 fives are 15. 15 plus 2, 17. So here it is 5. Here also 5. That's how I found out all the values from E to A like this. So the number I got is 142857. Now listen carefully. Sum of the digits. 7 plus 5, 12, 20, 22, 26 plus 1, 27. Answer for this question is 27. Answer for this question is 27. Decoding all the values of A, B, C, D and E. In case if you find it very difficult, what you can do is, you can do like this. Method 2. In case if you are comfortable in percentage related problems, there is a beautiful concept with respect to 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. 1 by 7, 2 by 7, 3 by 7, 4 by 7, 5 by 7 and 6 by 7. 1 by 7 value is, we all know that the value is 14.2857. 1 by 7 value is 14.2857 percentage. Now, to get a 2 by 7, what we will do? Take the numerator 2, multiply it by 10. What is 2 tens are 20, 7 twos are 14, 7 threes are 21. It goes maximum 2 times. So, write down this digit and the next digit, dot the remaining digits in serial order. 28.5714. If it is 3 by 7, take the numerator 3, multiply it by 10. 3 tens are 30. 7 goes how many times in 30? 4 times. Where is the digit 4? Here. Write down this digit and the next digit. Dot the remaining digits in serial order. 42.8571. 4 by 7. 4 tens are 40. 7 goes how many times in 40? 7 fives are 35. Write this digit and the next digit. Dot the remaining digits in serial order. That 6 digits are only rotating, sir. That 6 digits are only rotating. Now, if you observe carefully, this is the question that is asked. 14.2857, 42.8571. 1 by 7 became 3 by 7. That means 1 by 7 into 3 is 3 by 7. Yes, it is 3 times. It got leftmost one. That became the rightmost one. Remaining 5 digits are intact. That means directly if you know these 1 by 7, 2 by 7, 3 by 7, you can solve this question. If it is 5 by 7, 5 tens are 50. 7 goes how many times in 50? 7 sevens are 49. So 71.4285. 6 by 7. 6 tens are 60. 7 goes 8 times. 85.7142. This is how you can remember 1 by 7, 2 by 7, 3 by 7 and so on up to 6 by 7. I hope the idea it is very much clear to you. 1 by 7, 2 by 7, 3 by 7 and so on up to 6 by 7, right? So, if you know any question, leftmost one, right, 1 by 7 became 2 by 7, what will be the sum of the digits? It will be 27. So, if you know the percentage to fraction conversion for 7, then this question is very much easy. I hope the concept it is very much clear to you. Find the largest power of 3 that can divide 2010 factorial. It's a simple question. It is as equivalent to asking find the highest power of 3 for 2010 factorial. For 2010 factorial. How to find out the highest power of 3? 10 factorial. For these number, we need to find out the highest power of 3. It's a very simple process. Take the number for which factorial is present, divide these successively by 3. 3 6s are 18, 3 7s are 21, 670, 3 2s are 6, 3 23s are 669, 3 7s are 21, 3 4s are 12, 3 24s are 72, 3 8s are 24, 3 2s are 62. That means these are all, I am dividing 2010 factorial first by 3, then by 9, then by 27, then by 81, then by 243, then by 729. Are you all with me, sir? So, every power of 9 also contains 3. Every power of 27 also contains 3. So, adding all this, what will be the answer? 670 plus 223 plus 74 plus 24 plus 8 plus 2. All answer options, unit digits are quite different. So, this will be 3 plus 4 7, 7 plus 4 11, 1 plus 8 9, 9 plus 2 11. Answer unit digit should be 1. Answer unit digit should be 1. So, answer for this question has to be 1001. I hope the idea it is clear. Highest power of 3 for 2010 factorial. Take 2010, first divide by 3, then again divide by 3, right? Keep on dividing it by 3 till the highest power we got, such that it is not divisible further by 3. Good question, simple question. Highest power of 3 for 2010 factorial. Next one, right? Find the LCM and GCD. It's a very good question. 99% of the students will fall into the trap. I will tell you the mistake a student will do it. Mistake he will do it. The LCM and GCD of two numbers are 120 and 17. What will be the product of those numbers? Directly he will mug up the formula. LCM into HCF is equivalent to N1 into N2. LCM into HCF it is N1 into N2. Directly he will put the formula 120 into 17 is equivalent to N1 into N2. So, answer for this question, he will tick mark it as 2040. 2040 is the incorrect answer for this question. LCM into HCF, product of two numbers, it is an incorrect question. That means, what will be the concept behind this question? Remember, the concept is LCM into HCF, it is N1 into N2. This is used only LCM into HCF is equivalent to N1 into N2. It is only used when HCF is a factor of LCM. It is used only when HCF it is a factor of LCM. HCF should be a factor of LCM. HCF will divide the number, number will divide LCM. That means HCF should be a factor of LCM. That means 17 is not a factor of 120. 17, it is not a factor of 120. 17 sevens are 119. So, 17 is not a factor of 120. That means answer for this question is Data incorrect. Data incorrect. This is an incorrect answer. 2040, it is an incorrect answer. That is the reason you should not learn right concepts midway. LCM into HCF, it is product of two numbers. It is right only when HCF is a factor of LCM. It is right only when HCF is a factor of LCM. 17 is not a factor of 120. That means there is an inconsistency in the question. Answer for this question is data incorrect. I hope the idea it is clear. The last digit of the sum 2002 power 2005 plus 2003 power 2006 plus 2007 power 2007. So if you observe carefully, it is an even number. This is an odd number. 2007 also it is an odd number. Odd plus odd even. Even plus even even. Answer should be an even number. Even number will have an even digit, unit digit. That means 5 is eliminated, 9 is eliminated. Two options are eliminated just by looking at the question. 2002 power 2005. 2 power right, 2002 even number. Even number power any number, even number. Odd number power any number, odd number. Odd number power any number, odd number. Odd plus odd, even. Even plus even, even. Answer should be an even number. That means answer unit digit should be even. Answer unit digit should be even. Answer will be either B or D. Now let us find out. Right? Since he is asking the unit digit of 2002 it is 2. So it is 2 power 2005 plus here it is 3 power 2006. Here it is 7 power 2007. 7 power 2007. Till here it is clear. Only we are finding the unit digit. So what is the concept? Cyclicity of the unit digit is always 4. Cyclicity of the unit digit of any number, it is 4. Cyclicity of the unit digit of any number, it is 4. Cyclicity of the unit digit of any number, it is 4. Why it is 4? After 4 steps, the unit digit gets repeated. What is the divisibility rule of 4? Last 2 digits should be divisible by 4. 1005. 5 means it can be written as 4 into 1 plus 1. Only look at the last 2 digits. 6 it is 4 into 1 plus 2. 4 into 1 plus 2. Plus 7 power 7 it is 4 into 1 plus 3. 4 into 1 plus 3. You should know a concept in computing the unit digit of this kind of numbers. A power 4k plus 1. A power 1 after 4, right, it is A power 4k plus 1. A power 1 it is A. After 4 steps it will get repeated. A power 4k plus 2. After 4 steps it is gets repeated, it is A square. A power 4k plus 3. After 4 steps it is A cube. After 4 steps it is A cube. A power 4k plus 1 it is A power 4k plus 2 it is A square, A power 4k plus 3 it is A cube. So A cube is there. After 4 steps the unit digit gets repeated. A square is there. After 4 steps unit digit gets repeated. So here it will be A power 4k plus 1 it is A. Here it is A power 4k plus 2 it is A square. Here it is A power 4k plus 3 it is A cube. So this will be 2 plus 3 square it is 9. 7 cube it is 343. 3. So 9 plus 3 12. 12 plus 2 14. That means unit digit has to be 4. Unit digit has to be 4. Unit digit has to be 4. I hope the idea it is very much clear to you. We need to find out the unit digit of a number. Unit digit, how to find out? 2002. Unit digit it is 2. 2 power 2005. 2003. Unit digit it is 3. 3 power 2006. 2007. unit digit it is 7. 7 power 2007. Whenever we are finding the unit digit of a number, we need to look at the last two digits of the first power. Why we are looking at the last two digits? Because the cyclicity for the unit digit of any number is 4. So 4 ones are 4, remainder 1. 4 ones are 4, remainder 2. 4 ones are 4, remainder 3. It is of the form a power 4k plus 1, which is a. A power 4k plus 2, it is a square. A power 4k plus 3, it is a cube. So it is 2, it is 3 square, it is 7 cube. 7 cube, it is 343. 3. 3 square, it is 9, and it is 2. 9 plus 3, 12. 12 plus 2, 14. 14 means unit digit, it is 4. I hope the idea it is very much clear. The number of integers from 1 to 2009 that are relatively prime to 2010. In this kind of questions, we will use a concept known as quotient function. Quotient function application based question it is. Quotient function. Quotient function. Quotient function says if there is a composite number, n is a composite number. N is a composite number. Write this number as a power of prime basis P1 power A into P2 power B into P3 power C. Right? Number of numbers. This is tau of n. This is tau of n. Tau of n means number of numbers. Number of numbers less than or equivalent to n and co-prime to n and co-prime to n and co-prime to n. It is given by n into 1 minus 1 by p1, n into 1 minus 1 by p1, 1 minus 1 by p2, 1 minus 1 by p3, 1 minus 1 by p3. Sir, how you got it? Out of P1 numbers, suppose if you take any two consecutive numbers, one number is divisible by 2, one is not divisible. So if P1 is 1, out of two numbers, one is divisible, one is not divisible. So 1 minus 1 by P1. Out of, if P2 is 3, right? Out of three numbers, one number is divisible by 3. How many are not divisible? 1 minus 1 by P2. If P3 is 7, out of 7 numbers, one number it is divisible. How many are not divisible? 1 minus 1 by P3. So tau of n. This question is based on tau of n. So here it is 2010. 2010 can be written as 3 into 670. 670 can be written as 67 into 2 into 5. All the numbers I wrote it. 2 into 3 into 5 into 6, 67. So answer will be 2010 into, out of 3 consecutive numbers, 1 is divisible. How many are not divisible? 1 minus 1 by 3. Out of 67 consecutive numbers, one number is divisible. How many are not divisible? 1 minus 1 by 67. Here it is 1 minus 1 by 2. Here it is 1 minus 1 by 5. So this will be 2010 into 2 by 3 into 66 by 67 into 1 by 2 into 4 by 5. 4 by 5. These are all 2010 factors. So answer is 2 into 66 into 4. So what will be the unit? 2 6 are 12, 2 4s are 8. Answer unit digit has to be 8. Which answer option has unit digit 8? 528. Which answer option has unit digit 8? So this will be 528. I hope the idea it is very much clear to you. Tau of n will be n into 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3. What does this tau function gives? Tau function gives number of numbers less than or equivalent to n and co-prime to n. 2010 into 1 minus 1 by 3. Sir, how you got 1 minus 1 by 3? For every 3 consecutive numbers, one number it is divisible by 3. How many are not divisible? 1 minus 1 by 3. Out of every 67 numbers, 67 consecutive numbers, only one number is divisible by 67. How many are not divisible? 1 minus 1 by 67. 1 minus 1 by 2. 1 minus 1 by 5. So total answer for this question is, right answer unit digit should be 8. Only there is one option which is 8. I hope the idea it is clear. In fact, other way of looking at it is, now if you see here, 2 into 66 into 4. That means answer should be divisible by 4. Answer should be divisible by 4 means last 2 digits should be divisible by 4. 2009 not divisible, 1005 not divisible, 2010 not divisible. So answer has to be 528. I hope the idea it is very much clear, sir. Good question based on quotient function. A string of digits is formed with 2010. So there are numbers like this. One is 2010, next it is 2011, next it is 2012, and so on up to. If you observe carefully, 99, suppose for example, 990, 9991, 9992. These are the numbers. Serial order, it is written like this. Now, it is ending with 1999. That means till here we require. Till here we require. Are you all with me? Till here we require. Now, listen carefully, sir. Right? First it is 2010, second it is 2011, third it is 2012, and last one it is 4 nines ending with 1. Then it is 999. Then 3 more digits needs to be written. Then 3 more digits needs to be written. Concept. Now see here. Concept. Question, how many digits? Number of digits concept. Concept. Number of digits. Listen carefully, sir. Concept. If 1 to 9 is there, single digits are 1 to 9. Totally, how to find out? The number of numbers, highest value minus lowest value plus 1. From 1 to 9, how many digits numbers are there? 9 numbers are there. So 9 minus 1 plus 1. 9 numbers are there. Every number it is 1 digit. So totally 9 digits are written. Suppose from 10 to 99, 10 to 99, highest it is 99, lowest it is 10 plus 1. 99 minus 10 plus 1. Totally 90 numbers are there. Every number how many digits? 2 digits. 90 into 2, it is 180. 90 into 2, it is 180. Are you all with me? That means if 100 to 999 it is there. 100 to 999. Highest minus lowest. Highest minus lowest plus 1. Total 900 numbers are there. Every number 3 digits. Every number 3 digits. So it is 2700. This is how you determine the number of digits if they are written in the serial order. From 10 to 99, 90 numbers are there. Every number 2 digits. 92s are 180. From 100 to 999, total 900 numbers are there. Every number 3 digits. 900 into 3 is 2700. Similarly, from here to here we will calculate. So it will be highest value minus lowest value plus 1. Every number there are 4 digits are there. Every number there are 4 digits are there. 9991 plus 1, 9992 minus 2010. It is 17982. 17982 into 4. After this, 3 more digits are written. After this, 3 more digits are written. 2 fours are 8. 8 plus 3, 11. Answer unit digit has to be 1. Answer unit digit has to be 1. So answer for this question is 28,761. 28,761. Highly repetitive question that comes in your examination. The number is starting with 2010, 2010, 2011, 2012 and so on up to here. Number of numbers from A to B. Here we write down a concept, sir. Number of numbers from A to B, it is given by B minus A plus 1. Number of numbers from A to B, it is given by B minus A plus 1. So, B minus A plus 1, total 900 numbers, every number 3 digits, 900 into 3. 10 to 99, 99 minus 10, 89 plus 1, 90 numbers. Since they are 2-digit numbers, 90 into 2. Here it is 9 into 1, 9. Similarly, from here 2010 till 9991, total this many numbers are there. Every number 4 digits plus 3 more digits I need to add, plus 3. 2 4s are 8, 8 plus 3, 11. Answer for this question is option A. I hope the idea it is very much clear to you. At one time, 17th question, read the question. At one time, the population of a village near Hyderabad was a perfect square. Let these number be n. D is a perfect square. Let me call it as a square. Let the number be n, which is a perfect square, a square. Later, with an increase of 100, the population was, later with an increase of 100, n plus 100 is, it is 1 greater than another perfect square. It is 1 greater than another perfect square. Now, with an additional increase of 100, the population, additional increase of 100, n plus 100, additional increase of 100 plus 100, the population is again a perfect square. That means n plus 200, it is c square. N plus 100, 99, it is b square from these equations. N plus 99 is b square, n plus 200 is c square. That means c square minus b square, it is 101. 101, it is a prime number. So, only one way we can write. C plus b into c minus b is 101 into 1. 101 into 1. That means c plus b is 101. C minus b is 1. Adding 2c is equivalent to 101 plus 1, 102. C is 51. If c is 51, b will be 50. If C is 51, B will be 50. What is the question that we require? N plus 99 is equivalent to B square, or N plus 200 is equivalent to 6 square. 6 C square, 51 square, it is 2601. So, N is 2401. N is 2401. N 2401 means it is a 49 square. It is a perfect square. 49 square is a square. That means the value of a is 7. That means the value of a is 7. I hope the idea it is very much clear. A7 means it is a multiple of which number? 7. It is a multiple of which number? 7. Question looks relatively big, but actually it's an easy question. At one time, the population was a perfect square. Perfect square, I took that number as n, which is a perfect square. So, a square. Later, with an increase of 100, population is 1 greater than a perfect square. If I add 100 to n, answer is 1 greater than perfect square. If I add another 100 to it, again it is a perfect square. N plus 200 is c square, n plus 99 is b square. C square minus b square is 101, c plus b into c minus b is 101 into 1. That means from this we got the value of c as 51 and b as 50. See 51 if I substitute, n plus 200 is 51 square, n will be 2401 which is 49 square. 49 square is a square, that means the value of a is 7. I hope the concept it is very much clear. Good question it is. The number of 4-digit positive integers, the product of the digits is 210. So, A into, these are 4 digits, A into B into C into D, it is 210. 210 can be written as 2 into 3 into 5 into 7, 2 into 3 into 5 into 7. Are you all with me? It can also be written as 1 into 6 into 5 into 7. All are digits, right? So, 1 into 6 into 5 into 7. No other combination will be there. That means A 2357, 2357, 2357 can be distributed right among A, B, C, D. A can take any one out of 2357, 4 numbers. There is no repetition. That means remaining 3 numbers, anyone can come to B. Remaining 2, remaining 1. 12 twos are 24. There are 24 numbers that can be formed whose product of the digits is 210. 2, 3, 4, 7. 4 positions are there, 4 numbers are there. 4 numbers can be arranged in 4 positions in 4 factorial 24. Next it is 1657. 4 numbers are there, 4 positions are there. That means 4 into 3 into 2 into 1. 12 twos are 24. 24 plus 24. Totally, how many numbers can be formed? 4-digit positive integers whose product is 210. Answer is 48. I hope the idea it is very much clear to you. 210. What are the factorizations of 210? 2 into 3 into 5 into 7. Or 1 into 6 into 5 into 7. These 4 numbers, 4 letters, 4 factorial. 4 numbers, 4 letters, 4 factorial. Either this condition or this condition. 4 factorial plus 4 factorial. 24 plus 24. Answer for this question is 48. Good question. Only thing you might only consider this case. Consider this case also. You will get the answer. On particular year, 31 days of January contains exactly 4 Thursdays, 4 Thursdays and 4 Sundays. What will be January 1st? January 1st. Best way to solve this question is by using answer options. First option, if January 1st is Monday, second will be Tuesday, third will be Wednesday, fourth will be Thursday, fifth will be Friday, sixth will be Saturday, seventh will be Sunday. Seventh will be Sunday. Exactly how many Thursdays are there? 4 Thursdays. Let us see. If 4th is Thursday, 11th will be Thursday, 18th will be Thursday, 25th will be Thursday. 1, 2, 3, 4. 4 Thursdays I got. 4 Sundays. If 7th is Sunday, 14th is Sunday, 21st is Sunday, 28th is Sunday. How many Sundays we got? 1, 2, 3, 4. 4 Sundays we got, 4 Thursdays we got. That means 1st January has to be Monday. 1st January has to be Monday. Best way to solve is take the answer option and check it out whether the question statement is valid or not. Concept clear? 19th one. What is the remainder one? 1 factorial plus 2 factorial and so on up to 2010 factorial. It is divided by 21. 21 it is 7 into 3. What is the least factorial numbers that will have 7? 7 factorial. From 7 factorial onwards, all the numbers are divisible by 21. That means I will get 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial. From 7 factorial onwards, all are divisible by 21. That means the question is condensed to like this: 1 factorial plus 2 factorial and so on up to 6 factorial divided by 21. 1 factorial it is 1, 2 factorial it is 3, 3 factorial it is 6, 4 factorial it is 24, 5 factorial 120, 6 factorial it is 720 divided by 21, divided by 21. 6 plus 3 plus 1, 10, 10 plus 24, 34, 34 plus 120, 154, 154 plus 720, 874 divided by 21. Are you all with me? From 7 factorial onwards, all are divisible by 21. 720 plus 120, 840, 864, 870, 874. 21 fours are 84, 34, 21 ones are 10. I hope till here 1 factorial it is 1, 2 factorial it is 2, 3 factorial it is 6, 4 factorial 24, 5 factorial it is 120, 6 factorial it is 720 divided by 21, 21 it is 3 into 7. Now if you see here, listen carefully sir, what we'll do is instead of adding off all the numbers, 21 it is 3 into 7. Apply Chinese remainder theorem. That means all these are divisible by 3 plus 1. Answer when divided by 3, it should give remainder 1. Answer when divided by 3, it should give remainder 1. Over. So, this is how you can do a lot of simplified calculations. If there is more than one answer option, which when divided by 3 it gives a remainder 1, then you do the next part by using 7. I hope it is clear. From 7 factorial onwards, from 7 factorial onwards, numbers are divisible by 21. Numbers are divisible by 21. I hope the idea it is very much clear to you. All these are divisible by 3 plus remainder 1. Answer when divided by 3, it gives a remainder 1. Very beautiful. 20 questions we solved. Each and every question is a classical question that is very close to the CAT examination standard. I hope this question is clear. This is by using answer options. This is by enumerating all the cases. This is just by understanding the question. I wrote down the equation. Very important concept. This quotient function application. This is the unit digit application. This is where most of the students will do a mistake. Highest power related question. This is percentage to fraction. If you know it, you can solve this question. This is the greatest integer function question, alphabet repetition question, and understanding the question and finding out all the possibilities. Remainder based question, LCM when the negative remainders are same, divisibility related question, greatest integer related question, fraction to decimal related question, factor related question, and LCM related question. I tried to take each and every possible question which is very close to your examination standard. We will meet in the next class. Thanks a lot. With love, Anil Nair.